Yeah, so in this step number one, we want to calculate the flow rate at the operating conditions. As we discussed, the operating conditions are the 4000 kilopascal gauge and 4 degrees centigrade. And the inlet conditions are 18,000 meter cubic feet at, we can change it to the 18 degrees centigrade. So these are the inlet conditions and these are the operating conditions, and we want to find the flow rate at this one. And at this condition, the flow rate was 18,000 meter cube per day. So then the step number one, first of all, we need to look at the API gravity, how much API gravity we have. So we have API gravity 32 degrees centigrade. So then step one, what we did, we found the specific gravity using the API. And the formula is very famous, we all know using this formula. And we found the specific gravity, which is this one, 0.8654. Okay. And then if we multiply this specific gravity to 1000, we can get the uh, the density of the fluid in kg per meter cube at 15 degrees centigrade. So this is the density of the crude oil that we are transporting at 15 degrees centigrade. Okay. Now in the step number two, okay, we have density at this 15 degrees centigrade. Now we want to convert it into the 4 degree and 4000 kilopascal at the 4 degrees centigrade. So how we do this in this step, we have to apply the API correction factors, API pressure correction factors, and API temperature correction factors. Now, there was a question in the class that from where we get them. So, how we get them? We have this manual, okay, manual of petroleum measurement standards by the API. Okay, so if you have temperature and volume correction factors for generalized crude oil, refined products, and so using this manual, you can actually convert it. If you have a different temperature, you can always correction do the correction factors of this one. And based on this manual, there are many online calculators available that you can use to correct the factor. So in this one, I've used this one, which is the planetcalc.com. In this one, you can see that I put the initial density, I put the initial centigrade, and I put the initial pressure. So ambient pressure, here you see that the pressure was in the megapascals, the temperature in centigrade, and the initial density is kg per meter cube. So once I added these three parameters and I put the targeted operating pressure and temperature, the operating pressure was 400 kilopascals. I converted into the megapascal. So for targeting temperature of 4 degrees centigrade. So once I convert the calculate button, I got the density here, 875.3. So now using this calculate once, and here we found from the tables similar stuff, and we found this similar kind of density from here. So we have correction factors given by the API. API created a manual for it, and this is the manual that we have. Manual of Petroleum Measurement Standards, Chapter 11, Physical Properties. Okay, and data, and based on this, you can also convert the density at different pressure and temperature using these online calculators. Once you have it, you convert the density. You can using same correction factors here that we have. For example, for pressure correction, we have this 1.0026 here, and for API temperature, we have this correction factor. If you divide this correction factor, both of them, to 18,000, you will get the flow rate 17,794 meter cube per day. Okay, so the initial flow rate was 18,000 meter cube per day, but now you see the flow rate has reduced. Because why? Because the fluid got heavier. The density, you see at the 18 degrees centigrade, the density was 865. Okay, but density after you increase the pressure and reduce the temperature, the density becomes 875 with increase. So if the density is increased, means more mass per unit volume. So it means that now we need little bit lesser flow rate than the actual one to transport the same amount of crude oil, because density become higher. So we are now transporting the same kind of crude oil with less flow rate. So that's the part one of the question.